All right, today here in this video, we're going to actually examine what is a mole. There are a lot of different definitions or way to conceive of a mole. And usually, the first thing you find in chemistry textbooks or websites or lessons is this definition of a mole. 1 mole of a compound or an element is equal to this many particles of that compound or element. 6.02 times 10 to the 23rd. That is a huge number. Imagine if you wrote out 602 and 21 zeros. That's it. That's how many. That's what makes a mole, having that number of particles. By particles, we mean atoms, if you're talking about an element such as iron, or molecules, if you're looking at a compound such as water. This number is often celebrated by chemistry teachers and instructors. There is a National Mole Day that occurs on October 23rd. In my experience, however, as a chemistry teacher, I find this number rather useless. There's not much you can do with it. It's too darn big, and actually counting particles is kind of impossible. This number does have one importance, though, and it is to point out that a mole of any substance has the same number of particles as a mole of any other substance. And that factoid is important. But for the calculations that you're going to need to know how to do, this number doesn't really serve us much good. So I point it out here because you will need to be aware of it at some point in your chemistry careers. If you find this on the internet, well, probably a good thing that you got a little bit of it, you heard about it from me first, okay? But as far as I'm concerned here with my students, this is probably the end of that number that we're going to discuss. Here in distance learning, we can probably just put that one aside. So I ask again, so what is a mole? Well, now the best and most practical answer is this. It is a quantity of a compound or an element equal to its formula mass expressed in grams. Yeah, put a Z there. You like that? That's right. Last week, or maybe it was the week before, we learned how to calculate the formula mass. And formula mass is we expressed with a unit that looked like this. Hold on, I don't want to bleed onto the other page. Right? Formula masses were in grams per mole. Okay? Well, there's a reason for that. It's because the formula mass is the number of grams in 1 mole of a substance. 1 mole of a substance has a mass equal to the formula mass of that substance. Maybe an example will help. All right, por ejemplo, I think that's Spanish. Let's take our good friend salt, aka sodium chloride, table salt. All right, so let's calculate the formula mass of sodium chloride, aka table salt. All right, and there's 1 atom of sodium, whose form comes in at 22.99, and there's 1 atom of chlorine that comes in at 35.45. That's taken from the periodic table and rounded to 2 decimal places. And let's add 22.99 plus 35.45. And what do we get? We get 58.44 grams per mole. 58.44 grams per mole is the formula mass of our friend sodium chloride, but what does that really mean? That means that 1 mole of sodium chloride weighs 58.44 grams of it. 58.44 grams of sodium chloride is the same as 1 mole of sodium chloride. Here, let me write that down. I'll use a different color. So 1 mole of NaCl equals 58.44. This is squished in and sloppy. Sorry about that. Grams of NaCl. And that's it. So if you were in a lab and you needed to obtain 1 mole of sodium chloride, you'd go get a scale, you'd put on a little piece of filter paper or a weighing boat, you'd hit tare, and then you'd add sodium chloride to the scale until it read 58.44 grams, and then you would say, look here, I have a mole of sodium chloride. Now let's take water as another example, our good buddy water. Everybody knows water's formula, H2O. And I'll just tell you the formula mass for it. Water's formula mass is 18.02 grams per mole. So what does that mean? That means that 1 mole of water has a mass of 18.02 grams. 18.02 grams of water is the same as 1 mole of water, which is important to note here. It's important to see this right here and now, because a mole of sodium chloride is not exactly the same as a mole of water. That's right. Okay. This definition of a mole always depends on the substance that you're measuring out, or whatever, discussing, whatever the case may be. The mass of 1 mole of a substance is unique to it. Okay. So throughout all these calculations that I'm going to show you, instead of just saying 1 mole and a number of grams, I'm always going to say of substance, and you should do the same. Okay, thumbs up for that. Excuse me. All right, so there you go. That's what a mole is. If you want to find out a mole of something, how much it is equal to, just determine its formula mass like we did not too long ago. All right. Now, what do we do with that information? Well, some simple calculations today, and I'm going to teach you these calculations in a way that I would never do under normal circumstances. This is a way that I used to teach back in the day. I found better, more useful ways, but for simplicity's sake, because we're doing distance learning, this will have to suffice. It will be very important later on to take a mass of a substance and determine how many moles are in that mass of that substance. And vice versa. That's right. If you know the number of moles in a given substance, you want to be able to determine or calculate how much it weighs or what its mass is. Okay, and this little graphic here, this little sort of, I don't know what you would call this, a graphic, a diagram that I'm circling with pencil right now. This is what you can do to convert or change between the mass of a substance and the equivalent number of moles of a substance. Okay, I don't often tell when to multiply and divide, but again, this is a special circumstances. This will have to suffice. So if you know the mass of a compound, of a given sample, right? How do you determine how many moles that is? You divide that mass by the formula mass of the substance, and that will tell you the moles of the substance. See how the arrow goes? Okay. But what if you know the moles of a sample? Then how much would it weigh? Well, you would take that number of moles and you would multiply it. Get it? Multiply it, by the formula mass of that substance. And there you go. It's actually quite simple. But do note that in this, you're always going to do 2 calculations, not just one. Okay. The first calculation has to be the formula mass of the substance. So in a simple problem where you're going to convert between mass and the moles, you'll be given the formula of the compound. You have to first calculate that formula mass. Then, and only then, can you do this conversion. Okay? So every calculation really involves 2. And it's going to get more complicated later, as you will see. So here's a sample question, and you'll have a chance to practice some on your own. What is the mass of 0.37 moles of KBr? Really quick, if I did not have of KBr here, if I left out of KBr, you wouldn't be able to answer the question. Okay? Because the mass of 1 mole of one substance is not the same as the mass of 1 mole of another substance. So formulas are a crucial part of this thing. It's not a matter of just taking a number and plugging it away. That number is always going to be attached to a unit of measurement. That's always been important in chemistry, but now an extra dimension that is always going to be to identify the substance in the problem. All right, let's take out a thinner Sharpie and start doing this. So KBr, 1 atom of potassium, 39 point, where is it? 10. That's the mass of potassium from the periodic table, rounded to 2 decimal places. And then what about bromine? 79.90, 2 decimal places. Okay, since there's 1 atom of each, I can find the formula mass simply by adding those 2 numbers together. Let me take a moment and do that in my calculator. 79.90 plus 39.10 equals, 119.00 grams per mole. That, ladies and gentlemen, is the formula mass of this compound. Nice double zero, isn't it? It's like a nice even round number. But once again, 2 decimal places, even if they are zeros. Now that we've got the formula mass of this substance, we can consult this silly diagram in order to answer this question. We are given a quantity expressed in moles, 0.37 moles of KBr. We're asked to determine how much it weighs or what its mass is. So if we're given a quantity of moles and we want to determine its mass, we follow this arrow. We multiply that number by the formula mass of this substance, which we just calculated. So here we go, another thinner Sharpie. So we're going to take the 0.37 moles of KBr. We're going to multiply it by the 119.00 grams per mole. And we're going to get an answer. We're going to get an answer times 0.37. Uh-oh, I typed that wrong. 0.37. And that's going to give us a wonderful answer of 44.03 grams. That's right. So there we go. The answer to this question, what is the mass of 0.37 moles of KBr, is, whoops, there we go, back on camera here, 44.03 grams. Now, if you want to be fancy, you could write of KBr. Grammatically, that might be a little bit redundant, okay? But it's a good idea to start getting used to writing down not just units of measurement, but also the formula of the substance in question. Second example, here we go. This one's a little bit different. How many moles of sodium nitrate are there in 165.9 grams of sodium nitrate? So in other words, if I were to hand you a container and you weighed out, I'm sorry, let me try that again. If I handed you a container of sodium nitrate and you measured its mass to be 165.9 grams, with this calculation we're about to do, you can determine how many moles there are. Sorry about this. I don't have any whiteout. Maybe Caitlin, you can send some my way. Okay? All right, a little shout out to Caitlin over there for the whiteout. So let's answer this question. Again, we need to know the formula mass of sodium nitrate. So I'm going to try to do that real fast and kind of in a shorthand here because I know everyone's busy. So sodium's formula mass, 22.99. Yeah, we just did that one a little while ago. Nitrogen's formula mass, 14.07. Again, these are masses from the periodic table, rounded to 2 decimal places. And then oxygen, 16.00, but there's 3 of them. So we're going to multiply that by 3, and we're going to get 48. There's 1 sodium, so that would just get multiplied by 1. There's 1 nitrogen, that would get multiplied by 1. So I'm not even going to bother doing that because you all know how that works. And now we can add this, and this, and we can get a formula mass for sodium nitrate. So we got the, here we go, 22.99 plus 14.07 plus 48. Aha, gives us this wonderful 85.06 grams per mole. Great. Now, with the formula mass at hand, we can answer this question. Okay. How many moles of sodium nitrate are there in 165.9 grams of it? Again, we can consult our diagram. Okay. All right. The given quantity is grams. We are being asked to determine the number of moles. How do we go from grams to moles? We take that mass that's given, or that grams, divide by the formula mass, and that will tell us moles. The mass that's given in the question goes in the calculator first. It is the mass divided by the formula mass. So don't mix that up. Be very careful. Okay, so the mass given in the problem, stay on camera, 165.9 grammarinos. All right. And again, I'm going to keep the substance nearby. It's a good habit. We're going to divide that by the formula mass of it. 85.06 grams per mole. And since I'm running out of room here, I'm not going to put an equal sign. I'll put my nice arrow. And let's go to the calculator. We'll do 165.9 divided by 85.06. And we get 1.95 moles. That's right. That's right. It's moles of sodium nitrate. And there you are. I'm rounding answers to 2 decimal places as a kind of easy modified way of using the significant figure rules. What I'd like you guys to do is also round all of your answers to 2 decimal places. That's it. Okay? I'm going to have plenty of practice for you both today and the next time we meet this week. And so good luck with it. It's not all that complicated. But work hard because this is the basis of other calculations that will become complicated. Okay, my friends? All right then. Email me at any time with any questions. That means have a nice day.